Just think on the topic and then you reply back. We are having the
Sir, first of all, we have started hydrogen, sir. First of all, there was a position of hydrogen in the periodic table, where it is in which group and that one. So, sir, now where there we see that it has properties similar with the first group elements as well, like its electronic configuration is similar to the first group element, but sir, its chemical bonding property is similar to 17 group elements. So it has similarities with both first and 17 groups. So, sir, its position is debated; it is not fixed.
Okay.
So now next we have isotopes of hydrogen. The hydrogen generally occurs in three isotopes: protium, deuterium, tritium. So protium has one electron. Protium has one electron, one neutron.
No,
one electron, one proton.
One electron, one proton, no neutron. In protium.
Sir, deuterium has one electron, two proton. Tritium has one electron, three proton.
No, wrong. Again. Deuterium, you are saying deuterium, no? Deuterium. So deuterium 1H2. So this is the one is the electron. Here two are there, so one proton and one neutron. If anything is happening, two proton, do you know what will be the atomic number will change? If you are increasing the proton means the atomic number.
Okay,
so,
okay, sir.
no, you cannot say the two proton ever. Okay, one proton, one neutron, and similarly 1H3. So now tell the for
Sir,
1H3.
one proton, two neutron.
One proton, two neutron. This is what. Okay, that is okay. Very good. Now let us see the hydrides.
So tritium has a lifespan of 12.33 years, and it produces the beta rays.
Okay,
so
great.
Then there is that 9.2 preparation of dihydrogen. So hydrogen can be formed by adding this one to the metals. So it can be metal and can be formed with reaction of metals like zinc with the alkalis. So then we have commercial production. So commercial production is we can acidify, like put a very small amount of acid in a water so that it is formed as an electrolyte. So then we can perform the electrolysis on it. So then like this sir, BaOH, sir, this compound is also put under the very pure version is put under the nickel electrodes for the electrolyzing their solution. Sir, it is formed as a byproduct of byproduct of manufacturing NaOH. And that syngas processor where we are combining with CH4, so we are getting the syngas. So among the properties of hydrogen, we are having that it is a non-reactive gas which has no odor, but it is a highly combustible gas. It does not have any taste, but a pop sound. So in chemical property, we have that chemical property, sir.
Okay, no problem.
Chemical property, we have H2 plus halogen X2. So, sir, H2 plus X2 it gives 2HX. So where X equal to fluorine, the next electronegative is Cl, the next is Br, the next is I.
Okay.
So dioxygen always forms water with dioxygen. Dinitrogen forms the ammonia with the help of the Haber process. So reaction of metal forms the metal hydrides. Metal hydrides and metal ions, sir, it always reduces the metals. So now we have the use of dihydrogen. So dihydrogen synthesis of ammonia, then hydrogenation of vegetable fat used as a space vehicle. They're used as a fuel. So they use as manufacture of metal hydrides and manufacture of ammonia, which is the very important industrial chemical with the help of the Haber process. So now we are having the types of hydrides. So hydrides are formed when elements combine with hydrogen. Hydrides are mainly of three types. Ionic, saline, salt-like ones, covalent or molecular, and sir, this one, metallic or non-stoichiometric. So ionic are having ionics are having mostly the ionic bond between them. Covalent or molecular hydrides are having three types: electron deficient, electron precise, and electron rich. So electron deficient we are having less than octet. In electron precise we are having perfect octet or duplet. So in electron rich we are having the lone pair electron.
Thank you. Okay, good only. I am writing some questions. Can you read the question?
What type of hydrides formed by group 1, group 2, group 13? Group 14, group 15, group 16, group 17.
Okay. So
Sir, first of all, this group 7, this will be having the X ones.
name of hydride. Just now you told na that is 3 type of hydride. First one is ionic. Second is the covalent. Okay. And third
Sir, I
one is
think
the
this will be sir ionic only.
wait. Ionic, covalent, metallic. Okay, metallic. Covalent we
So
have
group
done
16.
covalent we done 3 types. We have done covalent hydride. That is the first one is
Electron
the
deficient, electron precise, electron rich.
deficient one. One is the deficient. Second one is precise. One was there, precise. And third one is the rich. Okay. So out of this all, we have to tell that is which one. If you talk about group 1 and 2, this is going to form the ionic hydride. Okay,
Yes,
because
sir.
ionic hydride like the LiH, NaH, these are. So group 1 and 2 these are going to form what type of hydride is Sanoy? This is going
Ionic.
to form the ionic hydride. Now, here if you talk about the group 13 and
So I think this
group
will be
13,
metallic.
no, group 13, how can it form metallic? It is the group 13 like the AlH3 is there, AlH3. Okay, BH3. So
Then sir it must be covalent.
electron deficient. They are the electron deficient. The covalent, but covalent what type? They all are the covalent. They all are the covalent, but the covalent are having the type. Okay, why they are covalent? Here because Al is having C, AlH3. So here is +3 charges there, na? So according to Fajan rule, did you study the Fajan rule? According to Fajan rule, it has greater covalent character. Greater covalent character.
Sir, we have not studied sir Fajan rule that one.
Okay, then that I need to make the video for you. Okay, I will make the video. In your school might have taught this one, Fajan rule? No.
No. Sir, it is actually not in the NCERT. Na, so sir, school did not teach.
It is there in the NEET. Full it is there. NEET it is there. Okay, Fajan rule is there and fully it is there. Okay. So, okay, by the way, I will explain what is happening. Achha, let us see. See, I am explaining the Fajan rule. First of all, you studied better. You studied the Fajan rule. Okay. So, FAZANS, Fajan's rule. What the Fajan's rule is explaining? It explain covalent character in ionic bond. Covalent character in ionic bond. Covalent character in ionic bond. Ionic bond. Oh, sorry. Covalent character in ionic bond. This is what is the Fajan rule. Now, first of all, you try to understand one thing. You try to understand that what do you mean by this? See, if it is the ionic bond is there, ionic bond. Okay, ionic bond. Okay, what is the difference if suppose a NaCl is there? So total electrons are there. This place are there. That is shared electron are very close to which atom? Close to electronegative atom. Okay. Otherwise, you can mention that is electrons are here only. All the electrons are here. Okay. 8 electrons are there. Shared electrons are, these are shared electron, but these electrons are here. Where? Near the chlorine. So this bond is shifting like that. So here is plus, this side minus. Now you see the covalent. If you talk about the covalent. So covalent bond, suppose I am taking the Cl, let us take the Cl. Okay. If you take the 2 Cl atom. So where the
So that is not
so this electrons are where? In between the two atoms. Exactly between the atom. Exactly between the atom. Getting my point? Between the two atoms. Exactly between the two atoms. This is there. And here in the ionic bond where the electrons are there towards the electronegative atom. Yes or no?
Yes.
Now what the concept here is starting now. If by any means, if shared electron or that is they are saying, or the transfer electron or bring back where you are bringing, or bring back to the center, or bring back towards the center of both atom, towards the center of both atom, then it has covalent character. Now just try to understand, ionic bond and covalent bond are differ, only one aspect are there, they are differing. The shared electron or transfer electrons are towards the extreme right, and covalent, the electrons are there in the middle. Are you getting this point, what I want to say?
Yes, sir.
Now, if I will talk about the, suppose AlCl3, I am taking AlCl3, or I am talking about AlH3. This is the +3 charge, yes or no?
Yes, sir.
This is +3. What they are saying, this Al will pull the electron towards itself. It is pulling the electron towards itself. So if it is pulling the electron towards itself, because it is the positive charge, 3 positive, it have, do you know, if you are talking about aluminum is atomic number 13, means the how much positive charge is there? Positive charge equal to 13 in the nucleus. And when it forming the bond, ionic bond, so this transfer the electron, right? This transfer the electron. Yeah, this has been transferred the electron. So transfer the electron means it is having the less electron compared to proton. 3 electron transferred. You must be knowing here, Cl, 1 electron transferred. So proton, it is already having +13, but electron how many left? This is the 10 electron only. So what this proton is going to do, this positive charge is pulling the electron. In the ionic bond, these are ionic bond, but electrons are being pulled towards the aluminum. So what is happening in the some sort of time, what will happen? The electron will be pulled back. See, this transfer electron will be pulled back towards the aluminum. And once the electron is being near the center, this is what is called, that is covalent character, yes or no? Generative.
Yes,
okay. So there are 4 condition are there. 4 condition. What are the 4 conditions that are?
I have one doubt here. Sir,
Okay.
sir, if you are if you are talking about this one, sir, AlCl3, so sir, this is pulling back its electron after some time. But sir, if I use some other covalent compound like NaCl,
no.
If we are having some other compound like this NaCl, sir, I am talking that if this one is the Na ion, this one is the Cl atom. Sir, what happened? It went away actually.
I don't know what. Now okay. So okay, there are 4 rules are there now. You need to wait.
Sir, I was saying that why that Na does not pull the electrons, whereas aluminum is pulling the electrons. That is my question.
That the question. That is, please give me a moment, please. Okay, now the rule 1. Rule 1 is smaller the cation. Okay, is smaller the cation. More the polarizing power of the anion. Polarizing power of anion. More the polarizing power of anion. What do we mean by polarizing power of the anion? Means that is pulling of electron from anion. This is what is it? Smaller the cation. Cation should be smaller. This is the rule number 1. Rule 2. What they are saying, the rule number 2, greater the charge on what? Greater the charge on metal cation. Okay. Greater will be polarization. Greater will be polarization of anion. Greater will be polarization of anion. Polarization means anion polarization means pulling the electron. So all the electrons are there. Suppose all the both the electron are here, negative charge. But so means only negative now, only negative, only negative. So it is only negative, so non-polar. Getting my point? Okay. So
No,
polarization,
no,
polarization
did not
means
understand.
wait. Polarization means
Sir, I
you
did not
polarize with
understand
the
what you told.
wait.
So that I'm
Polar
saying.
wait. Polarization means plus minus now. Polar means what? Plus minus. Only minus cannot be polar, only plus cannot be polar. They can be ions only. So these two
Yes.
electrons, okay, suppose that is the what I am saying. Suppose HCl are there, HCl. So what they are the both the electrons are here. So this is the what totally the negative charge is there. So only negative charge is there. You are polarizing. So how you are polarizing? You are pulling back the electron here. So the anion itself, what will happen if the any anion? How to explain to you? If you are like that gaseous state, you will study now. Gaseous state in the gaseous state, the electron it can go one side. Electron it can go one side. So and nucleus will
Yes.
go other side. Nucleus can go other side. So that is what the polarization only. Yes, no?
Sir, my doubt is, sir, like when suppose, sir, you just told about AlCl3, so I am using that only. So it was like AlCl. This has 6 electrons. Okay. So this one had 6 electrons. This one also had 6 electrons.
7 electrons, 7.
Sir, my question is, sir, when Al is giving the electrons to these 3, so then there it is the 8 electron formed. So each one is having the stable octet. So now you are saying Al is pulling this one towards this direction, right?
Yeah.
Al is pulling here. But sir, my question is, sir, if Cl is having 8 electrons, so Cl is having 8 electrons like this. So sir, that's the proton of the Cl also must be pulling this one. So then how it comes to the center by overcoming the force of this one?
But you need to see now the rule is what saying. The rule also we have to take care of now. Rule is saying that is cation should be small cation. So if the cation is suppose is nucleus is here and cation is very small, one cells are there. So this nucleus, the positive charge nucleus and the electron, what is the distance are there? Very less distance now. Size is less. So this nucleus can, if the size is small, this nucleus can pull the electron faster. But anion, see, any of the anion, it is having the larger size. Okay, any of the anion is having larger size. So if the larger size is there, so they cannot pull the electron. So they cannot pull the electron strongly. So what they will do? The electron can be pulled towards the cation. It is not totally pulling. That is partial covalent character. They are saying the covalent character in ionic bond. Few percent there will be the covalent character, not the 100%. Getting my point?
Okay, understood.
Understood. Okay.
Sir,
Anyway,
that was the covalent character, no, sir, that dipole moment mu observed by mu theoretical into 100%.
yeah. Correct. Now, that is rule number 3. See the rule number 3. Rule number 3. Greater the size of anion, more is the polarizability. More is the polarizability. POLARISABILITY. More the polarizability. Greater the size of anion, more the polarizability. Means it will give the electron. That is what they are saying. It will lose the electron. Means the electron will go towards the other atom and nucleus will go other side. Like see, Cl, that is shared electron are going one side, na? This side, towards the center. Okay. Towards the center here, towards the aluminum it is going, and the nucleus will be going the other side. That is nucleus will be here. So it is getting polarized. This is the electron are negative. This is the polarized. So they are saying greater the size of anion, more is the polarizability. So greater the covalent character. Greater the covalent character. Why greater the covalent character? Because electron will come in the center. Between the two atom, electron are coming towards the center, not towards aluminum. So if the electron coming in the center, that will be covalent character. Rule number 4. Last rule. Larger the, greater. In spite of larger, we are using the terms greater. So here is the greater the charge on, greater the charge on what? Greater the charge on which one? Anion. Okay, greater the charge on anion, more is covalent character. More is covalent character. Why? Because if more charge is there, so it is the polarizability will increase. It can lose the electron easily character. So I hope little bit you will be able to understand. These are the there. Now let me frame one question. What is question? I am having LICL. No, don't take the LICL because only the group 1 LICL is the covalent one. Okay, I am taking the another one. Okay, what is this one? BeCl2, Be MgCl2, CaCl2, which is having the greater covalent character?
BeCl2, MgCl2. So, anion is the positive charge one.
Anion is the what the Cl is anion. Here is a +2 charge is there, +2 charge is there, +2 charge is there. Cl is the same one. Cl is the same one. So which is the greater which cation will pull the electron strongly? Which cation will pull the electron strongly? Beryllium, magnesium, or calcium?
So smaller the cation, more is the parcels. Then it would be.
This will be the covalent, right? Covalent. Because beryllium will pull the electron.
Will be the most covalent, sir, because in the second period, sir, it comes like the second period it is BMg.
Beryllium is on the top.
So BMg. Then it is having the Ca. Ca, Sr. So then we are having Ba and then we are having Ra.
Yeah.
So nothing. So this one is the smallest one. So then one shell it is increasing. Sir, this Al and Ga, sir, these are coming later. So they are all 13 period elements.
No, here, wait. This is the question 1. This is the one question and this is question 2. Not the same.
Oh, so then also, sir, for this question 2, sir, the answer will be this one. So this one will be the highest and this one will be the lowest.
Yeah. That is what. Okay. Now let us come back to your topic. What we were studying. No. Okay. So this is the covalent, but this is the covalent means but precise one. This is the group 14 form precise. Group 15, 16, 17, they have the lone pair electron. So they are the electron rich. All are having the lone pair electron, so electron rich. Group 7, 8, and 9 are called what? Group 7, 8, and 9 are called what? Group 7, 8,
Sir,
and 9.
No hydrides are formed from 7, 8, and 9.
That is called hydride gap. Thank you very much. This is called hydride gap. Okay.
Sir, I did not know that I'm hydride gap, sir. I only knew that 7, 8, 9 do not form hydride.
So they are not forming only this, so there will be the gap now. These 3 groups are there. That is 7. This is the 8 and 9. They are not forming, so there will be gap now. They are not going to form the hydride. So that will be the gap. That is called the hydride gap. Getting my point?
Yes, sir.
What about this one? The last one. Which element of group 6 form the hydride?
So this one will be calcium, so Cr, chromium.
CrH, only one hydride it is formed. Transition metal hydrides are called. What we call transition metal hydride?
Transition metal hydride. So transition metal hydride.
Have you read about the non-stoichiometric hydride?
So non-stoichiometric hydride is only chromium from CrH. Yes, sir, it is open in front of me only, sir.
Except
sir, not red. So,
no.
sir, I just remember. Sir, I think this would be interstitial hydrides.
The interstitial hydride are also known as non-stoichiometric hydride. Ratio are not fixed now. That is why they are known as non-stoichiometric hydride or metallic hydride. They are the same name, metallic hydride. Metallic hydride. Okay, non-stoichiometric hydride, interstitial
So they
hydride.
can be the hydrogen storage. So this one.
Yes. Interstitial hydride. These are. Is it okay?
Yes.
Can I erase?
Sir, 1 minute. Just I am noting down the important questions.
Yeah, you can. The reasoning based question asked from this one, from the hydrogen mostly. There are some numerical based on the hydrogen peroxide that I will let you know.
So done.
Okay. So now you are saying that is we need to study the water also, right?
Yes.
Okay, water. You explain the shape of water. Then I will teach. Explain the
So
shape of
water is
water.
having a bent.
What is the bond angle?
Sir, bent tissue.
Why bend shape?
Bond angle. Bond angle. Sir, bond angle I have to see, sir. I cannot remember the bond angle.
Bond angle is the 104.5 degree. Why bent shape?
So it would be 104.4 degree 28 minutes.
That
So
is
it will be
round
having the
figure.
bent tissue.
Why bent? Why bent shape?
Structure will look like this.
What?
Oxygen. Sir, I'm drawing the structure first, so then I'm telling, sir, why that is the mention.
Today match, which team won the match? Do you know?
Sir, nothing, sir. What's it today, sir? I don't know.
Afghanistan beat the England.
But today it was Afghanistan, England, sir. I do not know who.
Afghanistan beat England.
So, but today's paper, everybody was saying that England was supposed to win. So it just came in today's newspaper.
Yeah. But just now I see that is England. Afghanistan beat England by the how many runs? 69 runs. Okay, no problem.
Sir, sir, this is because sir, hydrogen is sir, mainly the structure. So this is what we are writing in the form of Lewis one. But the main structure is like this. So there will be the two hydrogens over here. So the oxygen will have two lone pair. So like this. So sir, this will cause the disturbance here.
Okay, not a problem. So what is the hybridization?
This lone pair repulsion is there. So sir, it is more than the lone pair bond pair repulsion. So sir, this angle is reading 4.5.
Correct. So can you please tell me what is the hybridization and geometry of the water molecule?
So geometry of water molecules
Geometry, do you know?
Number of electron pairs.
Total
molecule
electron.
type. So this is the molecule type. So this is coming under AB2E2. So AB2E2. So this probably has this one.
Distribution of.
So this will
Okay. Tell me. So hybridization, you told what hybridization?
No, sir.
What is the hybridization state of the oxygen?
So hybridization state means?
What is the hybridization of this one? SP, SP2, SP3. What is this? See. Hybridization we study now. SP3, SP2.
Sir,
Distribution.
Sir, I cannot remember this one, sir. I forgot.
Not a problem. See, geometry means the distribution of total electron pair. Electron pair means lone pair and bond pair. Okay. So how many pair are there?
I think the geometry will be distorted tetrahedral.
Tetrahedral only. Geometry is the tetrahedral only. 4 pair, na? Tetrahedral. Okay, bond pair, lone pair, tetrahedral. Now, shape means the distribution of bond pair only. So only two bond pair are there. So that is how it will go. That is bent shape. Two bond pair means
Yes,
what
sir.
is
Bend
going
shape.
to bend shape. Okay, because the two lone pair not participating in the shape. Now, hybridization. See the hybridization, how to find hybridization. Either you go with the shortcut route, hybridization. Either you go the shortcut, or
So
the
tell me the shortcut, sir.
shortcut is the
Sir, we will do the shortcut only, sir.
1 by 2 in bracket B plus M minus C plus A. This is what is the anion. This is the anion with sign. Anion with sign, SIGN. And this is the cation. Cation with sign. If positive is there, so that is positive we have to take. Now, this is the monovalent. Monovalent. Monovalent means number of sigma bond. Okay, sigma bond. Sigma bond, not pi bond. If double bond is there, so we have to consider how many sigma bond. Can you tell me? One sigma bond.
So
And
one
if
sigma bond, y pi bond.
one triple bond is there, that is two sigma bond.
One sigma bond, two sigma, one pi.
Huh. So only we are hybridization means sigma bond. This is what number of valence electron. This is what number of V electron, valence electron. Okay. Now you see the H2O. If you are talking about H2O, central atom, 1 by 2, number of valence electron is how much? 6. Monovalence is 2, no cation plus no anion, 0. So how much it is coming? Hybridization is equal to, it will come 1 by 2,
Oh,
8.
this monovalent part I did not understand, sir.
Mono single bond, yeah. Monovalent means single bond. Single bond. Monovalent means mono means one bond. Monovalent means single bond. 8. So two, wow, how much will come? 4. 4 means it will come 1s and sp3.
And sir, one problem is this, sir. Sometimes I get very confused, sir, between this anion and cation. So, sir, any shortcut is there to remember this one?
Acha, anion and cation. Oh. Means sometime you miss out that is which is anion, which is cation, na?
Yes, yes, sir.
Yeah.
Okay, sir.
Okay. So negative is the anion is there, but you are getting confused. Anion, okay? And positive is cation. That is what cation. And see, cation. Positive is cation, loss of electron. Loss of electron. Negative anion, gain of electron. Sanoe, here is the, I can understand, it is the psychological error, right? Sometime I also
Sir,
missed.
actually, so now I can do actually. So my mother just told that like it is cation, so sir it has have T, so sir it will be positive like this. So sir, that will be okay. So we can continue, sir.
Like, okay, you can correlate with anyhow, because this is the common. Everybody is having somewhere, some students are facing problem left and right. Which is left side, which is right side, very
Sir, I
confused.
am also listening. Sir, I am also listening. Sir, left,
Uh,
right, greater than, lesser than. This
uh,
one, sir.
no. What is the, see, there is the rule is there, right? Rule is what is there? Rule is what? The no. Two rules are there. One rule I want to tell you. One rule.
Yes.
Once you identify problem,
Yes, sir.
identify problem, you will have problems. You will have the 100%. You will get the solution. 100% solution is there. What is solution is there? Practice that one. Practice. This is the one. Otherwise, its drawback is there. A small mistake. If these things are there, very small mistake. A small mistake. This will create big difference. This is. If, so what you need to do, you realize that this when your is problem, you just make practice 3, 4, 5, 6. Whoever is meeting with you, just discuss that one. 100% you will get the answers of this. Whoever, your friend circle also there, you can talk with them, you will be able to, right? So otherwise it will make a big difference. Very small cation anions are very little one, but it will create big difference. One more point, see, hybridization also, if you talk about hybridization also, you can say hybridization is equal to number of BP, number of bond pair plus lone pair. That way also you can determine, but number of bond pair plus lone. Suppose H2O is there, na? H2O. So how many bond pair are there? 2 bond pair. So bond pair is 2,
Yes,
lone pair is 2. How much total is 4? 4 means what? 1s, 3p. That way also. Suppose I am talking about NH3. Tell me, what is the NH3? Hybridization. Both the rule you see, hybridization is equal to 1 by 2 in bracket B plus M minus C plus A. If you solve 23 or 30 years now, this problem must have come. Many problems come. They will give 4 compound and they will ask the same hybridization state. You kindly...
Sir, it is coming, sir, but I am taking a lot more time on this problem. So I want to do it in a shorter way.
But you need to ask that one. It is taking time means you need to see how much time you give. You less than 1 minute you give, 45 minutes for one question. 45 minutes to 55 minutes.
So 55 seconds, na?
Second, yeah, second. Okay, sorry. Second, like that. See, you are having the 180 questions. 180 questions.
So 180 questions, 200 minutes.
200 minutes. 200. And some physical chemistry will take too much of time. Physics will get too much time. So if you chemistry means you take 30 seconds or something like that. How much it is coming? 1010 cancel out. How much will come? 90 I will come. I think the 90 second will come, no?
Only actually 9 by 10 says 0.9 into 60.
0.9 means
54 seconds.
54 seconds. So you are having very less time for that one. Chemistry, you take the as less as possible. Practice many questions are the repeated one, that it can be helpful. Okay, so 1 by 2 number of valence electron in the